Hello viewers, this is Prasanna. In this video I am going to discuss you 6th class unit 2 whole numbers. Here coming to what are counting numbers? 1, 2, 3, 4 so on. We use 1, 2, 3, 4 so on for counting things. Right? Counting things. These counting numbers are nothing but natural numbers. Natural numbers, and this natural numbers is denoted with capital N. So N is a set of 1, 2, 3, 4 so on. Here which is the smallest natural number? 1 is the smallest natural number. Can we say which is the largest natural numbers? So we can't. So doesn't exist. Okay, does not exist. Now coming to what is meant by successor. See, when we add 1 to any natural number, we will get a successor. For example, what is the successor of 1? 1 plus 1 gives you 2. So, 2 is the successor of 1. Coming to what is the successor of 2? 3. 2 plus 1 gives you 3. So, successor is nothing but adding 1. Then what is predecessor? Predecessor is nothing but subtracting 1. Okay? Means, what is the predecessor of 2? 1. What is the predecessor of 3? 2. Coming to natural number, every natural number has a successor. And every natural number except 1 has a predecessor. Every natural number has successor. Here, what is the successor of 1? 2. Successor of 2 is 3. Successor of 3 is 4. So, every natural number has a successor, but in natural number, except 1 has a predecessor. Means, for every number we are having a predecessor except 1 in the natural numbers. Here, what is the predecessor of 4? 3. What is the predecessor of 3? 2. Predecessor of 2 is 1. Then, what is the predecessor of 1? Here it doesn't exist because 1 is the smallest natural number. So in natural numbers, every number has a successor, but except 1, remaining numbers are all having a predecessor. Now when we add 0 to this 1, 2, 3, 4, means when we add 0 to these natural numbers, we will get another group of numbers. They are nothing but whole numbers. Whole numbers. Okay. Whole numbers are all natural numbers including 0. So whole numbers is denoted with capital W. So it is set 0, 1, 2, 3, 4 so on. Right. And which is the smallest whole number here? 0 is the smallest whole number. Now can you say which is the largest whole number? Here we can't say. Right. And in these whole numbers, even 1 is having a predecessor, but in the natural numbers 1 is not having a predecessor because 1 is the smallest natural number. But in the whole numbers, 1 is having a predecessor. What is that? 0, right? The predecessor of 1 is 0. Then what about the predecessor of 0 in whole numbers? Does not exist because 0 is the smallest whole number. And in whole numbers, all numbers are having successor, but for coming to predecessor, only 0 will not have any predecessor. Is that clear? And coming to are all natural numbers or whole numbers? Yes, all natural numbers are whole numbers because what are natural numbers? 1, 2, 3, 4 so on. So all these natural numbers will be there in the whole numbers. Now are all whole numbers are natural numbers? No, because 0 will not be there in the natural numbers. So by this we conclude that all natural numbers are whole numbers, all whole numbers except 0 are natural numbers. Is that clear? Now coming to here, we can represent these whole numbers on the number line. We can add, we can subtract, we can multiply on the number line. I will show you now. Now this is a number line for whole numbers. Here in this 0, 1, 2, 3, 4 so on, and on the number line always greater number will lie on the right side of smaller number. greater number lies on right side of smaller number. Coming to here, 0 and 1. Which is greater? 1. 1 is on which side? On the right side of 0. Right? Coming to here, 5 and 6. Which is greater? 6 is greater. 6 is on the right side of 5. Here, which is smaller? 5 is smaller. So, always greater number lies on the right side of smaller number. See, in this number line, we can add, subtract, multiply. Now, I will show you. Okay? Now, coming to first addition. Okay? For addition of whole numbers can be done on the number line moving from left to right. For example, 5 plus 3. Okay? 5 plus 3 means, suppose this is the number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5 plus 3. You know 5 plus 3 is 8. Now how to do this 5 on the number line from 0 to 5. 0 to 5. This is what 5. Okay. And we are moving from left to right side. So for addition you should move to right side on the number line. Coming to plus 3. So from 5 you should move to 3 places to right side. Okay. 1, 2, 3. So this is what 8. So you can do directly like this also. This curve is nothing but 5 plus 3. Is that clear? So 5 plus 3 is 8. You got 8 here. For example, on this number line, if I take 4 plus 5. Okay. 4 is represented with 0 to 4. I am moving from 0 to right side. Okay. From 4, this is 4. From 4, we should move to 5 places to right side. So 1, 2, 3, 4, 5. Okay, from here to here. So answer is 9. This is 4 plus 5. Coming to subtraction on the number line. Subtraction of whole numbers can be done on the number line moving from right to left. From right to left. For addition left to right, but in the subtraction right to left. So if I consider 7 minus 4. 7 minus 4 is how much? 3, right? Now first you have to represent 7. How will you represent 7? From 0 to 7. This is 7. Okay? Now start from 7. Take 4 steps to the left. Here minus 4, no? We should take 4 steps to the left. 1, 2, 3, 4. So here. From here to here you will get the answer. This indicates 7 minus 4. What is the answer here? 3. If I take one more example like 9 minus 3. How much? 6. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will represent 9 on the number line from 0 to 9. From 0 to 9. This is 9. And minus 3 means we have to move 3 jumps to the left side from 9. 1, 2, 3. Here this is the answer up to 6. So this is 9 minus 3. Now let us consider the multiplication of the whole numbers on the number line. So let us find 4 into 2. How much? 8. Okay. We know that 4 into 2 means taking 2 steps 4 times. Right? 2 plus 2 plus 2 plus 2. That is 8. Right? And multiplication is nothing but repeated addition. Right? Now coming on the number line, 4 into 2 means 4 jumps towards right side. Taking each of 2 steps. Here start from 0. Okay? Move 2 units to the right side. This is 2 into 1. 2. Next from here to here. Next 2 units. Next 2 units. Okay. So from 0 move 2 units to the right each time, making 4 such moves. So this is first move, second move, third move, fourth. See 2 2s are, 2 3s are, 2 4s are. 4 into 2, 2 into 4 is same. So we'll reach 8. So 4 into 2 is nothing but 8. So how many gems are there here? 4. Coming to another example, I take 3 into 3. How much 3 into 3? 9. Okay, so 3 gems you should make. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now, start from 0, move 3 units to the right side. And each time making 3 such steps because 3 into 3 here. Right? To reach 9. 3 3s are 9. 1, 2, 3. So 3 1s are 3 into 2, 3 into 3. Okay? Here this number is smaller. 8 and 9 we can draw on the number line. For example, if they ask you 6 into 5. What is the number 6 into 5? 30. So drawing on the number, writing on the number line up to 30 is somewhat lengthy, right? And we can't draw that much big number line using 1, 2, 3, 4 on the in the book, right? So what I do? 0, 6 table I take. 6, 12, 18, 24, 30, 36, so on. Now 0 to 6. This is what? 6 1s are 6. Next, 6 2s are 12. 6 3s are 18. 6 into 4. 6 4s are 24. 6 into 5. 30. Here how many gems you got? 5 gems. Similarly, you can write 5 into 6 also, like taking 5 table on the number line. Then you will get 6 gems. Is that clear? Multiplication of whole numbers on the